a moral reason you can't teach something because you don't know it that well?
Or you just
Yeah,
don't
because
believe
you're
in
not
it.
an expert.
Yeah, absolutely.
Well, maybe not even like, I understand if you don't believe in it, like I get that.
Yeah.
But if it's like a science, like neuroscience, and you're not an expert in neuroscience, would you feel comfortable teaching kids, college students?
No, we're going to have neuroscience in this course, but I'm not going to teach. We're going to read like experts and try to process it together and integrate it, right? Like I'm going to bring in, like the book I'm thinking about using was written by a neuroscientist, and he actually integrates Zen with it as well, and it's all about the nature of the self. But yeah, it's just, I don't know, and I'm super religiously sensitive anyway. I've always been like on the fringe of religion. It's always been a weirdo. So, yeah, I tend to feel persecuted quickly.
I understand that. Definitely understand that.
Yeah, let's see, I got some stuff to give y'all back. I already like put these grades, all your midterm grades are in,
Yeah,
which you probably know.
of course.
What is this?
What does everyone have?
I'm wondering as well. I don't blame you.
What time is it?
Pretty good day to be out. Sir.
Thank you.
Yeah, look how look that's your score after. There's your score in red after adjusting.
Pretty legit, dude. It's pretty legit.
Dr. T, he's not too big an asshole.
You gave actually, I should just look with my own eyes. Oh,
Let's see that.
wait a minute.
I didn't get anything from, right, you're good. Okay. Yeah, check it out, make sure
You have
it's,
to promise you weren't being really nice.
I mean, I can't promise that because I always try to be really nice, so.
Well, what?
Yeah.
Just stop.
No, I'm honestly just curious. And the only reason I'm asking is because I just don't see, like,
Dude,
any
no.
marks.
Any marks?
Yeah.
Well, as I look at it, I don't have to mark it if it's right.
I know, that's why I'm like, are you being like sometimes?
No. Just, okay.
Please. Thank you.
I mean, this man helped you today. You got to listen to what he says. Hey guys,
Jose helps me all the time. Jose's the good.
Jose
Go.
just seems like a generally helpful human being.
I'm just wondering.
Do you agree with that?
We will.
I think I probably have more
I
pages.
try to be.
That's your,
Somebody
there's,
needs help.
it's like that plus that.
But if they don't need help, I'm not
And
gonna
then
waste my
this
time.
is your school here.
No.
And there's probably some
How do you
pages
get
I
rid of
owe
that?
you. So,
2 p.m.
but
Not that
they're
bad.
in here and I'll find them soon. I was
Oh,
kinda,
like,
I think the latest.
yeah, I think so.
I drink
only
was
somebody
like
did this,
7.
so-
Awesome.
So I'd be
And awesome. I was worried.
Sometimes.
Well, that's-
I was worried.
Not all the time, though.
So we had a sheet of problems, and I'd said, like, let's have it done for today. How do you feel about that goal?
I just forgot to do it.
Okay, so you're also this, maybe different, I think everybody just didn't
I
do it.
didn't, well, no.
We were literally trying to solve.
We
Okay.
definitely tried to do it.
We were just
definitely tried to do it.
we were just busy with OChem the whole.
Got it, cool. How about you guys, you got them? You good?
I have a few done.
You still need a little
Yeah.
time. Okay, cool. Let me talk for a really brief, I just want to show you something I'm not going to ask you to do anything with, but I want to do just one example of surface area. I want to show you how to compute the surface area of a solid of revolution, and then I want to show you the horn, Gabriel's horn that we looked at, the infinite horn, just a little bit. So let me just give you a brief math talk, and I just ask that you just relax and follow along. And like I said, you don't need, you'll be good. And then we'll take some time to finish up stuff and answer questions. Alrighty, so the plan is this. We're gonna start with a very similar, did you ever notice that all my functions look exactly like that? X, y equals f of x, b. So our goal, spin this around the x, we're just gonna do the x-axis because that's all we need for this example. If you spin that around the x-axis, it is going to produce a bell with an open top, like so. Probably very used to seeing these things now. But now I'm imagining it hollow. So I'm imagining this to be a hollow thing, And what I'm interested in is the surface area of this. I'm trying to make those letters look warped, but I didn't.
Like the,
Yeah, I kind of gotta wrap it around. So we want the surface area of this beast. And guess what we're gonna do? We're gonna approximate it with straight things, take the limit as the number of straight things goes to infinity, and call it a day. But this one's a little bit fancier. So let me just remind you of this process, and I'm gonna do it in a little more detail than I normally do. I'm going to partition the interval a to b into n parts. And so that's going to be a is my x0 less than x1 less than x of n, which is my b on the end. So I'm making little cuts, just picking points. This is x0, but here's x1, here's maybe x2, x3, dot, dot, dot. One right before that is x of n minus 1, and then that's x of n.
Yes, sir.
Hi.
Really?
Oh, good. Hey. So we've seen this, right? Like a gajillion times. This isn't shocking. I hope that's not shocking. You're easily shocked if that's shocking. Like clutching pearls constantly if this is a shocking thing. So what we're gonna do then is pick points on the function right above those ends of the subintervals, like so. And I'm going to approximate the curve with straight lines connecting those dots. So, yeah, and then this is like dot, 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 because there's nothing in there, but like that. Now, would you agree that just looking at this, if I was just trying to find the length of that curve, this would be approximately that length, right? The sum of the lengths of the straight lines. I mean, this is what you do. If you have a ruler and you need to measure some crazy curvy thing, you take the ruler and you lay it on here and go, yeah, that's about 3 inches, that's about 1 inch, 2 inches, and then you would say, yeah, it's roughly this long. Is this making sense? I need to know. Alexander, I'm not getting a very confident yes from you, so I'm checking.
Yeah, I'm good.
Okay, you're good. Awesome, awesome. All right. So now spin that. What's going to happen when I spin that polygonal approximation? I'm going to get a shape that looks like this. So that first part's going to be very sharp, and then of course that's hollow, right? So like you couldn't probably see the other side, and then it's got this little shorter piece, and then it gets kind of flat here for a little bit. And it's looking like a bunch of stacked cans, and then dot, 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 and then out here at the end, you know, I've got this last kind of thing out here. Yeah, that's super shitty, I hate it. I'm not gonna put it. Leave it like that. Does that sound okay? Also, yeah? So it's just spinning these segments here, straight line segments. And you get these collection of these things that look like this. They are cones with the tip cut off and they're hollow. And I think I've put this up here before, but these are the frustrum of a cone. Frustrum is just a slice of a cone. So good so far? So what I'm going to do is figure out the surface area of one of these and add them all up and get an approximate surface area. So how do we do the surface area of such a beast? Well, its surface area is going to be, if that's R, and this, that doesn't sound good, and this is L, then the surface area is 2 pi RL. What a beautiful formula. Now this L is this distance here along the side, so it's not the height, it's the length of that slanted part on the side. Okay, so we kind of got to turn this in. Let's look at the ith frustrum out of this. So the ith frustrum is going to look like this, roughly. It might actually be facing the other direction. If the function's going down, the small piece will be on this side. We're going to base the height, so the height we're gonna approximate. We're gonna do a lot of approximate things here. Let me show you where this came from. It came from just one little piece that looked like this. This was x of I, and this was x of I plus 1. And then this height here was f at x of I. This height is f at x of I plus 1. How would you find the slope of that line? And let's call this length delta x of I down here. What is this L sub I here? Any suggestions on how to proceed? Let me start. I'm not doing hangman, I'm doing tips.
I was gonna say you could use like a trig function.
Yeah.
To find like a Pythagorean theorem relationship.
Oh, the Pythagorean theorem, there we go. The masterful, the theorem that unlocks everything, the Pythagorean theorem. So, I have a right triangle here. This base, I already know the length of, it's the distance between these two. This height here is the difference in the y coordinates. So it's f of x sub I plus 1 minus f of x sub I. And so the L sub I is equal to, thanks to Alexander, the square root of this thing squared plus this other thing squared. Sorry, ooh, easy boy. This length is, is this distance, this difference squared. I got a little excited. I gotta be honest, my brain started shifting back to that irritating meeting that I just had. Here we go. Let me get present. Does this sound okay? All right. So now I'm gonna do something interesting. I'm going to factor out a delta x of I squared. Square root of it. So in other words, let me show you the algebra here carefully. This is going to look a little weird. Okay, check that out. That's just algebra. But the way to see it's true is to bring these two square roots back together so that it's delta x sub I times this quantity inside. So delta x sub I squared times 1 is that. Delta x sub I squared times this beast is just this thing, because it cancels out the denominator. Any suggestions on simplifying this expression right here? Yeah, exactly. And the way we've written it, the delta x sub i's are going to be positive because we're doing right minus left. So that's just delta x sub I, and what I've got is something that you're thinking, my goodness, this looks terrible. And I agree. And we're going to make it look way better. So now, here's some calc you definitely do not remember from Calc 1. Unless you do, and then it'll be like, I'll give you like $1 if you remember this. I will be so...
I'm a betting man.
You're... All right.
Oh no. Calc 1.
Oh no.
Pull out the dollar.
You better just have it. If there's anything more than $1, I'm not pulling it out.
If you don't, if
If
you don't,
he's-
no, if you don't remember, you owe him.
I don't remember, do I owe you $1? Is that true? I would like that better though. I like those stays. Owing you $1 would be nice.
$1
Okay.
for whoever can grab this
You owe him your.
fact. So, let's look at this expression because we're going to replace it with something. So right now, here's x sub I. Here's x sub I plus 1. Here's the height is f of x sub I here. Height is f of x sub I plus 1 here. Just right over there. And I've got some weird function like this. Somebody tell me what the intermediate value theorem says.
Mm-hmm.
That's how you win the $1. No, excuse me, mean value theorem, mean value theorem. Mean value, yes, sorry, mean value theorem, MVT. You'll be the MVP if you know the MVT, and you'll have the dollar.
He says we did.
You didn't do the mean value theorem? Oh,
I don't think I've ever seen.
Is this like derivative still?
yeah, it's derivative stuff, so it's Calc 1.
I don't think he said mean value, whatever.
Who was your teacher?
Chavez.
Angel Chavez.
Oh,
He was only here 1 year.
well, now we see why. Oh, no, I'm just
I
kidding.
thought he was a good.
That was
I'm
my
not
time,
gonna.
No, he was great, he was a good teacher.
I like him a lot.
Yeah, he was
He
great.
didn't teach us that though.
He might have.
It's not
just
so
didn't
good.
say.
I still have the notepad, the note sheet.
If I have a function that is differentiable on an interval a to b, and I look at the slope between the start and the end, so this guy right here, this is f of b, yeah, it's starting to ring some bells, huh? Over b minus a, that slope of that line is what? With it, if f is differentiable. What do I know about that slope?
Is the derivative at some point on that line? That.
Equals f prime of c for some c on that line. That's exactly it.
Oh.
That this derivative. And he's buying coffee afterwards without his newfound dollar. Okay.
I can't take this dollar. This is so bad.
You're not happy with your dollar?
I didn't.
I mean, I'd give it to somebody else.
Can I double it? Can I double it and give it to the next person? Can I just do it?
Oh my gosh.
No, it's yours. I'm sorry you won. I'm sorry you had knowledge. I apologize. All right, so I think he might have told you about it.
Yeah, when you wrote that expression out.
Yeah.
Yeah.
So for some, that at some point in between the end and the start, the tangent slope achieves this overall slope. And you can kind of see it like right here. There's like a point right there where that tangent slope would achieve the overall slope. So that's what I'm going to use to carve this beast down, because I know that here, by Alexander's theorem, by the MVT, there exists an x sub I star that lives between these 2 points, such that the derivative of f at that point, f prime of x sub I star, equals that quantity right there. Delta x sub I. So I could replace this ugly thing with the derivative squared. So I'm just going to replace this quantity, the average slope, with the slope at a particular point. So let's do that. So this L sub I looks like this, square root of first derivative at that new point, squared, plus 1, delta x sub I. Yeah, does that look good?
Yeah.
I'm gonna add them all up, get my approximation. So sum of the L sub i's, this is our approximate. Oh wait, that's just the L sub I. We gotta actually do the surface area then. So then the surface, the ith surface area sub I, and we're gonna use this formula. Because we've got this frustum whose length along the side is L sub I, and we're gonna use that value of the function at x sub I to approximate the radius of the bottom, or I could just use f at x sub I plus 1 in that way. But this is going to be f at x sub I star right there. That's how high we're going to say it's approximately. So the surface area is approximately 2 pi times this L sub I delta x sub I, and then times what? Times the height, the f at x sub I star. So this is the height, or the r, and then this is the L sub I right here, this whole thing. I'm gonna add up all those frustum areas. So my total surface area is approximately the sum, and I'm gonna rewrite this in a slightly different way. I'm gonna put 2 pi out front, sum I equals 1 to n, square root of f prime of x sub I star squared plus 1 times f at x sub I star, just by itself, that's the r, and then delta x sub I. That sure looks like a Riemann sum. What happens as n goes to infinity? What does this become? You've seen this before, help me out. What does this
The whole
sum
thing?
become as n, as we make the cuts more and more, the delta x is smaller?
0.
More approximate.
It will become precise in the limit. What do these Riemann sums turn into? There we go. So it's 2 pi integral. That's what this is all about. These sums, when they become infinite, turn into integrals. That sounds right, doesn't it?
Yeah.
It's kind of like we've been doing it for a lot. No? So then the f's just get replaced, the estimations just get replaced with x's, or the specific points, f of x, and then the delta x always becomes a dx, and that's your surface area formula. Whether or not you can reproduce that, it don't matter. As long as you roughly believe it. And you have a sense like, yeah, okay. Probably couldn't do that on my own, but this guy seems like he knows what he's doing, so I trust him, more or less. So, let's use that formula to do, this formula sucks in a way because it often produces integrals we cannot do by hand. You'd have to use a computer to do it. So let me just give you a quick example. I probably have one in my book that will work. And it's so horrible that I didn't even put an example in. Apparently we're just going to use this on Gabriel's horn. So let's go back to that. I'm not going to make one up and have us sit here and look at it for like 2 billion hours, you know? Gabriel's horn. That came from rotating y equals 1 over x from 1 to infinity. I'm going around the x-axis. And so what we got was this infinite horn. Goes on forever and ever. This sounds familiar too, right?
Yes.
Okay, thank you. I just need some life. Just a little more than just staring at me. Okay, thank you. So I've got this. So we did the volume of this. The volume, let's just do it real quick, is pi integral, again this is 1 over x right here, pi integral, think about what our slices are, they're little discs, right? So we're just going to add up the area of discs, each of radius 1 over x squared, and we do that from 1 to infinity, dx. Good old, yeah, we've been doing this. This is like kind of on that page that you're maybe going to turn in today, maybe Monday. And when we worked this through, do you remember what the final answer was? Well, I do, and it's pi. Pi units cubed. This integral turns into 1. You just get it times pi. So it was pi units cubed for this crazy infinite thing. Let's do the surface area. Surely that should be fine. Or is it? Well, let's take a look. All right, now let's do the surface area of Gabriel's horn. We're going to use the formula. Surface area equals 2 pi integral across the range. 1 to infinity. Square root derivative. So our f of x here is x to the negative first derivative. That, which is that. I'm gonna square it. So we got 1 over, excuse me, x squared, negative x squared, and then we square that plus 1. And then we have that also times the original function. That's the times f of x part dx. Why do I feel concerned? I'm not asking you why I feel concerned. I just feel concerned right now about this. But we're going to keep going and see what happens. So I'm going to simplify. This turns into 2 pi integral 1 to infinity square root 1 over x to the 4th plus 1 times 1 over x dx. I got it. I know now. Cool. So tell me, a long time ago, I told you this fact that I know you probably don't remember, but it was one of the very first days we talked about this. And the fact was this, that if f of x is greater than g of x on some interval, then the integrals on that interval also kind of have the same relationship. Does that make sense? Seem right? I mean, just think of this as area. There's just more area under this f than there is under the g. And if we think of this as area, that makes sense. So this integral here, let's notice this. What is this always greater than? What number?
0.
True, agreed. Give me a higher number.
Infinity.
Not that.
100.
1. 1. Why? I agree. Oh, are we just guessing? So,
Wait, which one?
this quantity right here.
Is it
Oh,
converged
because
that
one
Oh,
over
whoa.
x to the 4th is 0, plus 1 is 1, no?
Yeah, so this is a positive number,
Yeah.
right?
And you're just adding 1 to it.
And we're just adding 1 to it. So I've got 1 over x to the 4th. Certainly we'll all agree with this. That's true, right? No matter what x is, as long as x isn't 0. But if it is, I guess this side's just hella big. So if I take square root of each side, I see that that square root is bigger than 1. So that means this whole integral, this surface area integral, must be bigger than 2 pi integral 1 to infinity of 1 over x. Because this thing is bigger than 1, so it makes, if I multiply this by that, it makes it a bigger integrand. Like that. Does that sound reasonable? I think Vincent's about passing out there. Do you see what I'm saying? That this function here
It's greater.
is bigger than 1. So this is like 1.01 or something. So when you multiply it by 1 over x, this is a bigger inside than this inside. Does that make sense? Does that help see it? Are you good, Kellen? Yeah, you're good. Kellen's like, I was good 10 minutes ago. Hey, what is this integral? But remember the p integrals. Remember the p integrals. Does this converge or diverge?
gets smaller, so it converges.
I think we better write this up again. I have these written on a little table that I keep right up here that you can't see.
P is greater than 1.
Yes,
If
if
it
P is bigger than 1, then
I
what?
think converges.
Converges. If P is less than 1,
Diverges.
or equal to 1, right? So this diverges. What does this integral do? What is P? 1. So what does it do? Diverges, thank you. So this equals infinity. So this integral is infinite. This integral is bigger than that. So this integral is infinite. That means the surface area is infinite. So hold volume is pi units cubed. The surface area is infinite. So I can take this Gabriel's horn and fill it with, I don't know, pi gallons of paint. Whatever units cubed would get me gallons. I can fill it with pi gallons of paint. Here it is, this piece of paint, it's filled all the way to the top. That's paint. But I don't have enough paint in there to paint the outside because it's infinite surface area and you could never paint the outside. What are the problems with this?
That doesn't exist.
It doesn't, who said that? Yeah.
Now the dog.
Wait, so when you say that, when you say more.
Okay, so you said you can fill it to the top with paint, meaning that there's like some bottom allowing it to fill up, but if it has infinite surface area, that would mean there's no like end to it. If you think about it from the outside, it doesn't ever end, and then end would zero. That's where I think about it.
That's cool, but we can have an unbounded thing with finite area, just like we can have it with volume, right? We're used to that because these integrals from 1 to infinity of x over p, they're finite even though this thing is infinite if p is bigger than 1, right? So we have this infinite thing that still has a finite area.
So it's saying like the inside has a finite area, but the outside has an infinite area.
Yes.
And that can't exist. Like
That it
that's
seems
not
like
equal.
it seems pretty messed up, doesn't it?
Well,
What are the problems with filling this with paint in the real world? What would be the problem?
you couldn't fill it up because like the outside it's the same, right? Like if you can fill it all the way to the top, then you should be able to paint the whole thing because like the outside of it's just flipped.
It would seem so, but let's get now. But
You
so,
keep saying that. I don't know what
I know.
that means.
So I know you don't. That's why I'm trying to be consterning. But seriously, like let's just think about filling it with paint. Why couldn't you fill the entire Gabriel's horn with paint?
Because it keeps going. To infinity.
And it keeps narrowing, right? At some point, this will become narrower than an atom of paint. At some point, this will be tinier than the tiniest cork. And nothing's going to go past that. So first off, filling this with paint, impossible. Not even something we could do. The other problem is mathematical area and mathematical volume just don't make sense. They are not things to compare. You can't compare them to each other. You can't compare something of a certain dimension to something of the next dimension.
Oh, it's like cubed.
Exactly.
It's like squared.
And so just like the way these ideas seem so intuitive and like natural, but they're not. And this kind of exposes a weakness in that thinking right here. Because it is impossible. It's utter nonsense.
Because it's not dimensionally consistent. That makes sense. But
There you go.
I didn't like think about it like that.
That's what
I
I'm
never
here
think
for.
about the units.
Anyway, that's all I wanted to tell you about today. Infinite paint cans. But it does, like the inside is already painted if it's filled, right? It's just weird. So anyway, if you are done with that assignment for today, I'll take it. If you are not, let's spend the last 15 minutes working on it.
I agree. That's a good idea.
I think it is a freaking awesome idea. And I am going to get a chai. And I'll be right back. Since I think we all need to get started. Not all of us, but many of us. You're done?
No.
Oh, okay.
No, we were
We've
working
been
on
working on it for 9 hours.
Okay, so I shouldn't say that. I don't have a big deal.
What did you say?
You've been working on it for 9 hours.
No, we haven't.
Okay, but you have been working on it.
Yeah, we have.
Yeah, I was like, where'd you get the 9 hours?
Yeah. Well, yeah. I mean,
Was I
Keep
asleep?
cranking, I'll be right
it's been
back.
9 hours since.
Do you actually have a
I started.
question right off the start?
Oh, yeah.
Oh, well, let's talk.
No, I'm going to try.
You sure?
Because it's kind of turning into a conversation. I know it, so please.
I have this feeling you're right. You're right.
Spectre things or no? What? Like,
He's going to go get a chai and then get back to you.
like, is he allowed to like tell us if we got it or no? Oh.
Has to. Bro, this is, what word you got in tries? You can. Right? Or no? Or just like a take one. use case says I should tip. Doctor with it.
What you doing, bro?
He's gonna see this.
Are you gonna see this? You probably won't. We just upload it. Then people will see it.
Before I start something to ask him. We agree for this problem.
Which one?
The one, the whole letter.
Which one?
Congrats.
What the heck, we're just doing it all, we haven't done anything.
Well, we had.
Well, I don't.
Did you write it?
I'm about it, well, I know what it is in my head, I'm about to do it right here.
You actually did it? Why 2,000?
Cause that's how much the class is,
But you didn't use the care for it.
but they don't have to
Okay,
do
this is
that.
y equals
So
4,
they're not gonna
we have 0
re-apply.
and 2. Maybe that's not in here too.
That's how much it is anyways, normally. It's more expensive at Denver Health than any other spots I've been looking at too. And any other
then-
spots are too far anyways.
What was the other one? We were about x is
I
1.
wanna try to.
Okay, so theoretically, the volume should equal, this is, so
Well,
x-axis.
no, because I still need a job.
Volume.
So once I get EMT cert and I get a
E2
job,
pi
then of course I'll do
integral 0
Plus,
to
if, it depends,
x,
because.
I don't know what x is, but
Depends on the schedule, but they kind of,
Isn't X
most
zero?
likely gonna have to take like really late night classes. And then I don't
You
think.
can see this x bit right here.
Isn't it 0?
Well, that's what I
Anyways,
thought,
it's
is x equals 0.
So
So I'm gonna put it there, and then we're gonna ask him, so this is x squared.
I mean, sure, I can go quote unquote the easier route, scribe, and all those stuff, but FFMT is so much more interesting.
Okay,
I'll do something.
and then for the y-axis, volume should equal
Also, EMT is pain.
pi integral between 0 and 2. Yeah, times 4 squared minus x squared squared dx. dx.
You should look for.
We agree.
You don't want to do scribe.
Right.
Wait, didn't we have for the X one? Didn't we flip these two now?
Oh, it's, yeah, we did, you're right. It's 4x squared.
I made something that says.
All right. Let's talk.
Okay, maybe, do you agree with any of these things?
Oh, okay, well, that's an interesting question. Is this right?
No, I asked you. if you
Well, that's an
agree.
okay question. I'm cool with that.
Cause it's gonna lead, where.
Is that a 0?
That is, see, that's where we're gonna talk.
Yeah, that ain't, that's not right.
So what is this? What is that?
That's an X.
Yeah, and so what, so what?
Sorry.
No, it's all good, it's all good.
Yeah.
I know that.
I wasn't trying to be a
No,
smart
no,
ass.
I know you weren't, and that was kind of the answer I was egging on for, so.
Okay, so why isn't there an X?
So should I just like put that there?
Well, you definitely shouldn't put 0.
Well, I know that, and that's.
Or
the-
T.
I know.
Just kidding. Yeah, but so tell me, what are we doing here? So we're taking this region
Okay, so this,
between these two.
yeah, and then, so when y is 4.
Mm-hmm.
So
Yeah,
x
perfect.
2, right, 2 squared is
Awesome.
4, we agree
Yeah.
there. So it's between these intervals.
Mm-hmm.
The volume for the x-axis is the formula. is
I think
this.
this looks
So then
fantastic.
we have this
That's
minus volume,
perfect.
and then we have top minus bottom.
But so this is reversed. This is the formula. This is the about the y-axis
Well,
because
no,
Yeah.
the y-axis
This
says
is about the X.
pi, x-axis is 2 pi.
Oh shit, these are asked backwards.
Oh, that's what. Oh my gosh.
Well, how did you guys know they were wrong though?
Because we looked it up, Dr. T. What do you think? Of course.
Oh, of course we looked it up.
What do you think?
Oh my god, this sheet is messed up. It should say.
But I was a bit. I was like, no, it's fine. The internet's just always wrong.
Yeah, we were like.
So I was going off.
No, you guys, just anytime this happens, you think I'm wrong, check with me, because I might be wrong.
Well, we didn't know.
We didn't know.
No, I know.
What'd you get wrong?
So on this sheet that I handed out,
Okay, the formulas you gave us.
it should, the about the y-axis and about the x-axis are backwards. Yeah, so
And I was wondering too. We were doing this in the chemistry. I'm like, I wonder if these are backwards.
they
man.
are, your intuition is right. Yeah, I'm sorry you guys spent 9 hours on this.
No, it's okay.
Not what you didn't spend.
Yeah, we
I
did.
know you did.
Yeah, we did.
I know, yeah, okay, you did, I'm really sorry.
Straight too, no breaks.
Well, I paid you $1, what do you want? So the one with the pi is about the x-axis, the
Okay.
one with 2 pi is about the y-axis.
So
Got it.
this-
I'm so glad we talked. Which who's
This
this?
is mine, but we can still talk though.
Yeah, we can still talk about
Now
it.
that we've gotten past that hump.
Now that we've gotten past
Okay.
that fairly colossal hump.
Okay, you know what happens? Okay, so then if I were to just do one of these motions
Yeah.
and then say X, that's correct.
Yes, it
Alright, cool.
So does this look good?
So that looks,
Because X.
yeah, that's beautiful. You guys got it.
Okay.
Yeah, you understand.
No,
yeah.
here's
You
the
don't
real
understand,
question.
That's not
okay.
the
No,
real.
so we were pretty confident in this. The
Yeah.
only reason we had a question is because the internet said it was the other way.
Yeah, the
That's why-
internet,
Why we were
the
like,
internet's always right about everything.
Okay, fair enough. So, could you help
Mhm.
to find these things?
Well, that you have to have a certain scenario. You show me the scenario.
Okay, so, alright. Y equals 5.
So this next problem here.
Fine.
No, it's cool. It's cool. Okay.
I don't even wanna know. I just wanna know.
You understand.
I wanna
You
know
want
how
to
to-
understand.
Here's
Draw me
this,
the picture.
Here's this. I know we have like.
Yeah.
I'm gonna use 5. I'm sorry. I'm gonna use 5.
Yeah, 3 wouldn't work anyway. It would be
I know because
inside
that's
the.
inside. I know that's why I'm flipping it because it has to be above 4.
It's okay. I'll walk
Okay,
you through this.
So we have y equals 4, and then above here is y equals 5, right?
Correct.
So then this is y equals x squared 0 and 2. Okay, whatever. So,
Oh, like while you're in.
referring to this, y equals L,
Mhm.
outer radius x. So the outer radius of this is rotating about 5.
Mhm. So draw me a typical element. Show me a slice of the area.
Like just in the middle.
Anywhere, somewhere, right? So you just pick a spot and go all the way up to the line y equals 4. Okay, stop. Cool. So that's what we're spinning around y equals 5. What shape is that?
It's like a washer.
Washer. Beautiful, beautiful. So this is the center of rotation, this y equals 5, right? Yeah?
4.
Or no, y equals 5 is the center of rotation. This is the top of the region we're rotating. But the axis of rotation is 1 unit above both, all that
Yeah,
stuff.
yeah.
Okay? So as I spin this, what part on that line you just drew will be on the outside?
The part that's
Just at the bottom, right?
like
So,
this bit.
so look, can I just show, do you mind really quick, just show you, I think this would be a better place, and let's just mark that as X. So how far is that? Oh, wait, sorry, okay, that's 4, so what is our outer radius? Cause our radius comes from the center line, right? Do you want me to do this? Let me do this on the board, so you can.
I'm having a hard time picturing like the outer and inner radius of the 3D part.
Yeah, that's what this is all about, so that makes sense. It's not something you came in here knowing. God, dang it. Thought I had something decent to be.
You have a marker in your hand.
Thank you. Thank you. Alright, so I'm gonna do it a slightly different, so there's y equals x cubed,
Right.
yeah, and then there's 20, let's make that 8, and then here's 2, and here's my region R. And I'm gonna spin that around the line, y equals 9,
Yeah.
okay? So, I'm gonna draw a standard element, x. I'm gonna show a slice right above that. And you want this labeled so that when we do the vertical axis, we have that x in mind, because we're gonna need it for reference, for sure.
Okay.
So, now the question is, so as I spin this thing, Alexander, here's the axis of rotation. This point of this slice is on the outside, right?
Yeah.
This point right here,
Uh-huh.
that's on the outside.
Yeah.
What is the distance from the line
Oh.
to that point?
Yeah. So before, it is 9, but before we go on, is the
It's not fully
at y
nine.
equals 8, where the top of the x region is,
Yes,
it is fixed to that point.
correct.
It does not move.
There's gonna be a big hole through
Yes,
the middle
yes,
of
yes,
this
yes, yes,
solid,
yes,
yeah.
yes. So now I can see why this is creating, because this comes about and then leaving, like, I get it.
Do you see that, Othman?
It's like, it's like you're taking like that shaded represents, wait, can you draw like a 2D washer?
Yeah. So think of this strip that I've got here, Othman, rotating around this line here. And you're gonna get a shape that looks like that, and it's gonna,
And then that shaded region is the distance from the
this is,
outer
So
part.
from
to
eight,
the-
from 8 to 9,
Yeah, I got it.
from 8 to 9, it's all, yeah.
so, I'm sorry, say that again.
So if you were to take your marker and
Yeah.
you were to put it on the edge of that inner radius circle,
Uh-huh.
and then, yeah.
That's the outer radius.
That's what that represents.
That's what this distance is,
Yes,
yes.
yeah.
Right.
And
What is that distance?
9. Oh, sorry.
If it was always 9, this would be a big cylinder, but it's not, it's changing.
9x.
How far is this distance right here?
I don't know.
Well, yeah, you do. It's x cubed.
From x to that point.
From the x-axis to that point, that's x cubed, because this is y equals x cubed.
Okay.
Does that make sense?
No. Cause that's. Oh.
I mean, if I asked you to graph y equals x cubed, you would pick a point, and you would go up the cube of the x coordinate.
Yeah, just go on.
No, I'm not going on.
No.
If this point is 1, if x is 1, how high is this? How high is this distance right here? Look at the function. What is the y coordinate relative to the x coordinate?
1 cube.
So if this is x, this is x cubed, that distance there. It's gonna change as I move back and forth.
Yeah, I gotcha now.
Okay.
X is dependent.
So what is the outer radius? It's not 9. 9 is this distance.
Is it 9 minus x cubed?
Yes, it is
Yeah,
9 minus x
yeah,
cubed.
Yeah.
Yes. Yes.
Okay, I got it.
You got that? So here my volume, I'm gonna use the pi formula, integral from 0 to 2, that's the slice range. And then I've got here my outer radius is going to be 9 minus x cubed squared. That's outer squared. Outer radius squared. We have more to do, because we still have to subtract out this chunk of the inner radius. Because right now, if I just do that integral, it's as if there's no hole in the center. And I've got the shape riding all the way up there. Or actually, it would just kind of be flat like that, a flat edge. So I have to subtract out the hole in the center. What is the inner radius?
I don't understand why it's subtracting 9 if it's fixed to y equals 8.
The 9 is the axis of rotation. It has nothing to do with that 8, really. Except for this next part. What is the equation of this line that runs across the top right there? There you go. I have to subtract out that spot. Because otherwise my whole radius is this distance right here. So I'm gonna say, you're just gonna have to struggle with this a little bit, but I'm gonna put it up here. What is the inner radius? Alexander, come on man, what's that distance
It's
right?
one.
There you
But
go.
It's not,
It's not that? What is the trouble?
okay, alright, so you're saying the distance? Like 9 minus x cubed makes sense of like what it represents in terms of that point
Uh-huh.
at x.
Yes.
Okay, however, that sliver that you have written out in the region stops at the 8 line.
Yeah.
Okay, so
Yeah.
why are you taking why is that that's not the outer radius though, because the outer radius should, well, I mean, obviously it's not, but I see it as 8 minus x cubed because it's fixed to that.
If I
point.
rotate it around y equals 8, absolutely.
So
Then I would have no hollow center at all. And you're right. If I rotate around y equals, bye guys. Yes, you want to turn it in? That's cool. Awesome.
Yeah.
Thank you,
I
gentlemen.
was gonna see if you could check over to see.
Well, I'm kind of in the middle of something right now, so you're gonna have to wait if
That's
you want
okay.
me to do that.
It's fine.
I'm
I
happy
think
to
I
do it,
trust
but you gotta wait.
I think I trust it.
Okay, okay,
I hope.
sounds good. If I rotate around y equals 8, this is the answer. No, I mean, actually, no, that is, yeah, that would be the answer. But I'm not rotating around that, I'm rotating around 9.
So why didn't you draw it up to 9? Why
Because I want a hole in the center.
But so that would it would run into it.
What would run into what?
I don't know. It still makes a hole in the center though, doesn't it? If you're fixed on 8.
No.
No, doesn't.
If I roll around 8, it looks like a thing with a solid top. Like that.
Well, that wouldn't even go through, right?
Oh, this wouldn't go through, you're right. Yeah, because we're doing solid stuff here, so to stop it.
You
If
want
we
to
have
see
a top curve and a bottom curve, you will have a hole. If you're not rotating around the top curve, you will always have a hole.
Think about it.
Yeah, look at the, there, oh, this might
No,
help.
I'm not confused on that geometry. I get what's happening. I get like what the shape it makes, but okay, so you're going onto this inner radius where you're taking the difference of 9 and 8 right there,
Yeah.
right?
Uh-huh.
So obviously that y equals 8 is relevant.
Yeah, it is relevant. 100%, that's how we got 1.
That's the.
I agree. If I do this, y equals f of x, I think the straightness of that is maybe screwing you up. G of x, rotate around this line, y equals L. Take this region, rotate around there. It's gonna be a hole in the center, right?
If it's like fixed at g of like right where g of x.
Just look at that region. If I rotate that around this line, there will be a hole in the center. Not a straight hole, but it will be hollow. Are you sure you believe that? I don't think so either.
But I did earlier though. I should stop.
I think we should stop because I don't think this is gonna, yeah, this isn't helping, it's frustrating you.
If you look at the video, look at,
No,
start
no,
out.
it's good, it's good. I had this, I had the visual earlier. It's fine.
Once you regain it, it'll be stronger.
For this, go to
Nah, it's
minute
good.
40
I'm
in
not even getting
the
it.
video.
I'm not even getting
I'll look at it and maybe ask a question.
Very good, we can.
See, Greg, why don't you come in on Monday before class and see how you're feeling about all of this?
it. Alright.
Good.
Bye, see ya. Oh,
I'll have this by Monday.
that sounds great. That's cool. Just get it to me on Monday.
Yeah, I was quite busy this week.
All good.
Like, are there things I have to take in next week?